Welcome to my 8th class on complex variable 1. In this lecture video, we'll be discussing a few more problems on type 1, type 2, type 3 and type 4. Problem number 1. Show that f of z is equal to e power x cos y plus I sin y is holomorphic. This holomorphic is nothing but and the function has to be proven like it's an analytic function. They have given that f of z is equal to e power x into cos y plus I sin y. The first thing is I'm taking e power x inside the bracket and I'm replacing the function f of z as a complex variable, that is u plus iv. So I got u plus iv is equal to e power x cos y plus I into e power x sin y. So now I'm separating the u and v. So I got u is equal to e power x cos y and v is equal to e power x sin y. So differentiating u and v with respect to x partially, treating y constant, I got dou u by dou x is equal to keeping cos y as it is, differentiating e power x, I got e power x itself. Similarly, differentiating v with respect to x, I got dou v by dou x is equal to keeping sin y as it is, differentiating e power x, I got e power x. Similarly, differentiating u and v partially with respect to y, treating x constant. So I will get dou u by dou y is equal to keeping e power x as it is, cos y will become minus sin y. Dou v by dou y will be equal to keeping e power x as it is, sin y will become cos y. So I got ux is equal to e power x cos y and vx is equal to e power x sin y. Uy is equal to minus e power x sin y. Vy is equal to e power x cos y. So we can say that this ux is exactly equal to vy and vx is equal to minus times of uy. So this is a required condition for CR equations, that is ux is equal to vy and vx is equal to minus uy. So it implies CR equations are satisfied. So once the CR equations are satisfied, we can say the function f of z is an holomorphic function or regular function or it's an analytic function. So I got f of z is equal to e power x into cos y plus I sin y is holomorphic. Problem number 2. Show that f of z is equal to z power n, where n is a positive integer, is analytic, and hence find f dash of z. So since the function having f of z is equal to z power n, so if I take z is equal to in the Cartesian form x plus iy, so I'll get x plus I whole power n. The function will become very complicated and I can't find the u and v easily. So for that purpose, I'm going to replace this complex number as in terms of polar form, that I will be replacing z is equal to r into e power I theta for this problem. So I got f of z is equal to z power n. Since f of z is a complex variable, I can replace it as u plus iv and I'm putting z is equal to r into e power I theta in terms of polar form. So I got u plus iv is equal to r into e power I theta whole power n. So on expanding this, I got r power n e power I n theta, and we know how to expand e power I n theta. It is given by cos n theta plus I sin n theta. So I got r power n cos n theta plus I sin n theta. So taking r power n inside the bracket, I got r power n cos n theta plus I into r power n sin n theta. So I got finally u plus iv is equal to r power n cos n theta plus I into r power n sin n theta. So now equating the equations both LHS and RHS, I can take u is equal to r power n cos n theta and v is equal to r power n sin n theta. Now we have to check for the CR equation. For that purpose, I'm going to differentiate the equation u and v with respect to r partially, treating theta constant. So differentiating u with respect to r partially, so I'll be getting dou u by dou r power n will become n into r power n minus 1, keeping cos n theta as it is. Similarly, v will become dou v by dou r, keeping sin n theta as it is, r power n will become n into r power n minus 1. So I got ur is equal to n into r power n minus 1 cos n theta and vr is equal to n into r power n minus 1 sin n theta. Similarly, differentiating u and v with respect to theta, treating r constant. So dou u by dou theta is equal to keeping r power n as it is, cos n theta is minus n sin n theta, and dou v by dou theta is equal to keeping r power n as it is, sin n theta will become n cos n theta. So I got the expression like u theta is equal to minus n r power n sin n theta, and v theta is equal to n r power n cos n theta. So I can simplify this u r as n by r power n cos n theta. So I'm just rewriting r power n minus 1 as r power n by r. Same thing here also. So I got the expression u r is equal to n by r power n cos n theta, vr is equal to n by r power n sin n theta. So I'll be getting r ur is equal to n r power n cos n theta, r vr is equal to n r power n sin n theta, and also we have u theta is equal to minus r power n sin n theta, and v theta is equal to n r power n cos n theta. So from these two equations I can take r ur is equal to v theta, and from these two I can say r vr is equal to minus u theta. This is required a condition for to satisfy CR equations in terms of polar form. I can say CR equations are satisfied. It implies the function f of z is equal to analytic. Now I'm going to find f dash of z with the help of ur and vr. So f dash of z is given by e power minus I theta ur plus vr. So I'm keeping e power minus I theta as it is. In the place of ur I'm putting n r power n minus 1 cos n theta. In the place of vr I'm putting n r power n minus 1 sin n theta. So I got e power minus I theta n r power n minus 1 cos n theta plus I into n r power n minus 1 sin n theta. I can take n r power n minus 1 common factor. I got e power minus I theta into n r power n minus 1 cos n theta plus I sin n theta. This cos n theta plus I sin n theta can be put like e power I n theta. So I got n r power n minus 1 e power I of n minus 1 theta. So I got n into r power n minus 1 e power I theta whole power n minus 1 I can write. Since here powers are same, I can combine these two. So I can write like n into r power r into e power I theta whole power n, and this is nothing but a z, right? So I can put this as z here. So I got n into z power n minus 1. So since they have given the function f of z is z power n, so like after differentiation we'll be getting n z power n minus 1. The same value we got here also. Next problem. Show that f of z is equal to r plus k square by r cos theta plus I into r minus k square by r sin theta, for r is not equal to 0 is regular function of type, z is equal to r into e power I theta, and hence find f dash of z. So this sum also like same like previous problem only. First I'm going to find the value of u and v. Later I'm going to find the value of f dash of z. So given f of z is equal to r plus k square by r cos theta plus I into r minus k square by r sin theta. So now I'm going to separate u and v here. So since we have f of z is equal to u plus iv, so I can take u is equal to r plus k square by r cos theta, and v is equal to r minus k square by r sin theta. So differentiating u and v with respect to r partially treating theta constant, I got ur is equal to 1 minus k square by r square cos theta, and vr will be equal to 1 plus k square by r square sin theta. Like how means differentiating r, I got 1 by r will become minus 1 by r square. Same thing here also, r will become 1 minus 1 by r is it will become minus 1 by r square, it will become plus 1 by r square. So from this one I can take r common factor. I'm taking to LHS. I got r ur is equal to r plus k square by r cos theta from ur equation. Same thing here also, taking r common factor here. I got r ur is equal to r minus k square by r sin theta. Similarly differentiating u and v with respect to theta, I got u theta is equal to keeping r plus k square by r as it is, differentiating cos I got minus sin theta, and same thing here also, dou v by dou theta will become keeping r minus k square by r as it is, sin theta will become cos theta. So I got u theta is equal to minus of r plus k square by r sin theta, v theta is equal to r minus k square by r cos theta. Now so we can say that from this equation we can say that this r ur is equal to minus of u theta, and this r vr will be equal to v theta. 1 minute, yeah. We got expression like now. From this expression we can say like r ur is equal to r plus k square by r cos theta we got. So these two equations are exactly same. R ur is equal to, we can write like u theta, and this r vr will be equal to v theta here. So I got the CR equations get satisfied here, that is r ur is equal to v theta and r vr is equal to minus u theta, we got it. So hence we can say the CR equations are satisfied. It implies w is analytic. So now I'm going to find f dash of z. To find f dash of z, the formula is e power minus I theta into ur plus vr. So it will become e power minus I theta into keeping ur as 1 minus k square by r cos theta and vr as 1 plus k square by r sin theta. So I got e power minus I theta into 1 minus k square by r cos theta plus I into 1 plus k square by r sin theta. So it implies e power minus I theta into, so from this one expanding the equation, so 1 into cos theta, I into 1 sin theta I am taking here, minus k square by r cos theta, again taking negative common factor, so I got minus I sin theta. So it will become e power I theta, it will become e power minus I theta here. So e power minus I theta minus k square by r square e power minus I theta. So now what we can do means I'm going to combine, I'm going to take this e power minus I theta inside the bracket. I got e power minus I theta minus k square by r square e power minus 2 I theta. So it will become 1. So I got 1 minus k by r e power I theta whole square. I got f dash of z is equal to 1 by 1 minus k square by z square by replacing r e power I theta as z square. As z, so it will become k square by z square. Example number 4. Given u is equal to x square plus 4x minus y square plus 2y as a real part of an analytical function, find v and hence find f of z in terms of u. They have given u function here. So from this u function we are supposed to find the function v, and also we have to find the value f of z. So for this purpose, I'm going to differentiate u equation with respect to x first. So differentiating u with respect to x partially, treating y constant, I got dou u by dou x is equal to 2x square plus 4, it will become 0. Similarly, differentiating u with respect to y partially, I got dou u by dou y, these two will become 0, minus 2y plus 2. So I got dou u by dou x as 2x plus 4, dou u by dou y as minus 2y plus 2. So since we have to find the value of v here, I'm going to convert dou u by dou x, dou u by dou y in terms of v function. So it will become dou u by dou x is equal to dou v by dou y, we can replace. Dou u by dou x is equal to minus dou u by dou y, we can replace. This is because of CR equations. So now I'm replacing dou u by dou x as dou v by dou y, dou u by dou y as my dou v by dou x. So I got dou v by dou x is equal to 2x plus 4, dou v by dou x is equal to 2y minus 2. So now differentiating dou v by dou y with respect to y, integrating dou v by dou y with respect to y, treating x constant, integrating dou v by dou x with respect to x, treating y constant. So I got expression like v is equal to integration of 2x plus 4 dy plus constant f of x. Again this one, v is equal to integration 2y minus 2 dx plus constant g of y. So after integration, so I got v is equal to 2x will become 2y, 4 will become 4y. So I got v is equal to 2x5 plus 4y plus f of x. Here 2yx minus 2x plus g of y. So now to find the value of this f of x and g of y, we have to compare the equation. So choose f of x from this equation, the term which is free from y variable. So I can choose f of x is equal to minus 2x because this term not having y variable. Similarly, to choose g of y, choose from this equation which is free from x variable. So I can choose g of y as 4y. So after replacing these two values in the v equation, the v equation will lead to what? 2xy plus 4y minus 2x will be getting. So once we got the value of v and u already we are having, I am going to use this equation. So f of z is equal to, I got u plus iv. So replacing u as x square plus 4x minus y square plus 2y plus I times of v is 2xy plus 4y minus 2x. So I'm putting x is equal to z and y is equal to 0 here. So this will become z square plus 4z minus 0 plus 0 plus 0 0 minus 2z. So I got the expression f of z is equal to z square plus 4z minus 2iz. Thank you.